Okay, welcome aboard everybody. Thank you very much for joining us today. Today's online event is around Hypersaline Water, a serious challenge for concrete infrastructure. We'll just walk through some housekeeping and the agenda items. So we've got on board with us today Doug, Hamlin and Hayden Prestidge, our experienced presenters. Doug, do you want to give us a little bit of background about yourself?
I could probably introduce Doug while he's sorting that out. So Doug's been with us for 14 years, I think now, and a large array of topics through there, but now very focused on the civil and mining infrastructure scope, and very thankful for Doug's technical background. And then myself, Hayden Prestidge, good to see you all. Thanks for jumping on. I'm been with MARKHAM for coming up 10 years now, came into the construction industry, but very concrete focused now on all commercial infrastructure mining projects across Australia, New Zealand. So thanks for joining. Brendan, back to you.
Yep, thank you very much both. And I'm Brendan Stead, and we're dashboarding here today. I've been with MARKHAM for about 10 years in a variety of roles. Now, if you have a look down the bottom right of your screen, you should see a little circle with that question mark in it labelled questions, and there's also a chat button there. If you'd like to drop any questions you have along the way in the questions button, we'll have a session at the end where we try to answer as many of those as possible. But just right now, in the chat box, could you just share with us what your background is, what industry you're coming from, and so on? We'd love to know.
Yeah, thanks. I'll just back that. Really will encourage. I know a lot of you on here, very good background, very technical, sound knowledge. I'll be really interested in your questions and comments through this. So yeah, please do that. And if you can put some info in the chat now, it just helps us sort of tailor and think about what type of environments you're coming from and how we need to, what we need to address. So.
It's excellent. Civil construction, including desalination, mining in a hypersaline environment, civil construction manager. Good to see what's coming in there.
That's good. Thanks. Well, keep that
very much. Let's keep that going, and we'll try and play it along as we go. Now, just on the learning outcomes for the event, the three main questions are: why is hypersaline water a challenge for concrete? Where do the issues most commonly come from? And what can we do for protection and durability? Hayden, if you could take us away, why is hypersaline water a challenge to concrete?
Thanks, Brendan, and thanks again all. So let's look at what hypersaline water is first, as a component. So saline obviously means salty, and often used to refer to a solution of salt and water. Now the hyper bit becomes in because the concentration or the solution is so high, is a technical term referring to that, and it's generally around 3 to 4 times. It can vary, obviously, that of salt water or seawater, and so you can see that build up, that high concentration of salines and the chloride in there, the sodium chloride. So there's other salts, obviously, that come along with it, and as do many other minerals, sulfates, heavy metals, all those sort of things that come along with that type of water. But we're really focusing in on the hypersaline aspect of this session. And along with it, with this water, it does have very high acidity levels. So the acid is again a key component of why we need to protect concrete, those sort of things. And it does play with the pH levels. So all these aspects of hypersaline water are really a condition that can have detrimental effects on concrete. So let's look at that now. So that's sort of outline what hypersaline water is: a very high concentration of salt and water. And so this is where MARKHAM really comes from. Our sole purpose is to add service life to concrete, and that's why we often think about this. How does this sort of environment affect concrete, and what's the issues here that we're trying to protect? Concrete is very porous, at microscopic level, and this hypersaline does carry into the concrete, and it builds up and it can eat away the cover concrete. So it really damages your structural integrity. It leads to that sort of premature deterioration of the concrete cover. Now, as you lose cover on the concrete surface, it just becomes more and more porous, allowing more contaminants, and obviously gets through to the depth of steel. We see things like expansion, cracking, spalling, breakouts, obviously leading to all those, or stemming from this environment. It really breaks down the strength, the acidity. It starts eating away and plays with the concrete there, and then along with that you get sulfate attacks, etc., which leads to that expansion, cracking, etc. And all these things decrease the life of a structure and really pull back its durability and its ability to do what it needs to do to perform. With that, also, it does bring a lot of maintenance issues and ongoing maintenance problems. And as you would know, and we know, taking a structure offline, especially once live or full of water or operating, is a costly exercise. So that's really how it affects. But it's really, I suppose we want to focus on the structural integrity and what type of projects this, or what type of structures. Let's have a think about that. So if we can just jump to that next slide, where do these issues occur? And it's good to see a number from the mining industry here, because this is a very common one. And you think about that water that's coming out of the ground, the bore water, often full of very high concentrations of salts. So hypersaline water coming up, bringing with it all these minerals, sulfates, heavy metals, etc., that can come and attack concrete. Also, you think about the return water of processes that are used through mining, often obviously going back through to a tailings dam, things like that, and very high concentration, often multiples of what you'll find with typical seawater. Local councils and water authorities is a big one. So where they're treating water, not only even into like the wastewater type scenarios where you get that acid attack on concrete, but also even soft water, potable water will have some effect on concrete. Desalination plants is a big one. Obviously, you are working directly with salt water, and that build up, that brine, and that protection needed, or that need for something to give it more life through that. And then obviously coastal environments is that we get in that wet and dry cycle. As with any of these structures, actually, the wet and dry cycle is a big player too, because you get that wash and then you get that hypersaline going through it, and you get that build up and loss of cover. So that's the sort of structures we're thinking. No doubt you might have a couple more on your list, so feel free to put questions in as we go as well. But that's, if we can. So that's some of the challenges. We've looked at what the hypersaline is. We've looked at what type of projects it does. But let's have a look at what can be done. So Doug, hopefully you're ready to roll now.
Yep. How does that sound?
Good.
Yeah, thanks, Hayden. It's a good overview there of the hypersaline. So I guess first and foremost, it's really important to understand that while concrete looks a solid waterproof material, it's not at a microscopic level. And this is because as the concrete forms, as it cures, the bleed water escapes out of the concrete, and you get left with a porosity or pathways in the concrete that moisture can get back into the concrete. Now, this is obviously there's a lot of good efforts that go into, design, constructing the concrete, making sure the mix designs line up with codes, all those sort of things. But even with all that, you still get this porosity in the concrete. It's just the nature of the material. So with that, thinking about that moisture, or thinking about those pathways, they carry moisture through the concrete, and that the impact of that is that it also carries contaminants through the concrete as well. So such as chlorides in a marine or in a hypersaline environment. These could be many other contaminants that get carried into the concrete and move through these porosities as transported by the moisture there. So it's really important when you're talking about concrete service life to close that porosity or seal that porosity up, and that's where we at MARKHAM come in. Our technology that we work with, the hydrogels, the colloidal silica particles, they work to seal that porosity up. They form a gel inside those pathways and stop that moisture transmission from the surface of the concrete down into the matrix. Which does two things. It stops the contaminants getting into that matrix, that cover concrete, and then it also prevents contaminants getting down to that reinforcing steel and starting that corrosion process. Now we do have we'll cover it off a bit later on. We've got a report that looked at a car park in Vancouver that goes back to the early 90s. And this was looking at both the acid rain that they get there, and then also the de-icing salts that get tracked in on the car tyres, and proving some very effective durability performance there. So we'll look at that again shortly. The preventative maintenance topic, as many of you will be aware, being in the engineering asset management space. The earlier we can get on and protect something or prevent something from happening, the better. The thing with concrete deterioration is that it's a self-feeding cycle, so it's not a gradual or linear. It doesn't progress linearly. It's exponential degradation that happens. So once you start getting that damage start to manifest, it moves very quickly to cracking, spalling, starting to need major repairs, that type of thing. So that's just really highlighting the need to get that protection on, ideally at day one, with admixtures, good concrete design, and then if you don't get that window, protecting it as soon as possible after that. Before that damage starts to really show, and that gives the best outlook, best service life expectations for that structure. So just on that, we're not saying with the hydrogels that we completely stop any attack, anything like that, but we push that curve as far as we can in terms of the service life, and give that structure the best chance of a long service life. Right, now this is some facts and data I'm sure everyone's going to be interested in. So we've just done some recent testing alongside with our hydrogels, the Acuron 300, Conquer B50, alongside calcite. Now calcite is a very well recognised and high performing admixture in the market there. This is not in any way to downplay the performance of calcite. It's a very well respected admixture and commonly used, and that's why we wanted to do some trials up against it. Now these were carried out independently with Boral. Firstly we looked at some field testing, which as you'd all know has some challenges with variability. Concrete testing, that type of thing. But what it did show is even with those sensitive mixes, we were still able to get good results with the Acuron 300 in that example. with some significant improvements both in the water penetration and chloride diffusion. Strengths were much of a muchness there. Then we progressed to the laboratory testing, which was, we looked at strength again and the water penetration. As you can see there, in that controlled environment where you haven't got that variability of the field, we are on par with the calcite admixture there, so performing very similarly. And what's interesting is even on a nearly 80 MPa concrete, you're still getting that 7 mils of water penetration into that concrete. That's using the British standard 12390-8, which puts samples under a 50 metre head pressure. So yeah, it still demonstrates that it's got that porosity, and then you can see the subsequent reduction in permeability there. There is a couple other things when we're dealing with durability admixtures, waterproofing admixtures in this space, and that's the workability. So the mixing and placing on pumping, that sort of thing, shotcreting on site. And with the hydrogels, they are friendly towards those attributes, and you do get a very good mix with limited or heavily reduced cracking compared to some other mixes out there. The handling and logistics factors, so that's the safety, and looking at the safety around dosing, that type of thing, and the physical quantity of admixture required. There's some very good advantages there with the hydrogels, being a nil VOC and potable water safe admixture, to be able to be used safely by your teams, by the staff there, and then obviously not have any negative impacts while they're pumping, placing on site. So yeah, I think that's enough on that one. If we could move on. Just wanted to talk about a few projects now. So one project we're privileged to be involved in is the Carrapateena mine site in South Australia. Now this has very high levels of hypersaline water, and we've been involved in protecting the new structures both underground and surface, and providing that a good quality concrete right from day one, so it places well, you get limited cracking, those types of things, and couple that together with the fact that you're getting a waterproof concrete, protects against that hypersaline water from getting into the concrete and breaking it down from inside. Hayden, over to you.
Yeah, cheers, and just thanks for the questions that are coming in. We will make sure we answer them at the end. So keep firing them into the questions or the chat down the bottom there, bottom right. We'll get to them soon. So if anyone's on the call from the Sydney area, may well recognise this Anzac Bridge, but Glebe Island. Now that why we're talking about this one, it's really interesting. Obviously, it's marine environment, but it was actually used to load salt onto. So actual had raw salt sitting on it. So that combined with obviously weather and the moisture, the seawater, etc., really harsh environment on the concrete. And we got involved to treat that. So existing structure now, we've talked a lot about admixtures. Now this is an existing structure, being able to spray apply to the surface, penetrate in and close that porosity to existing structures has been very beneficial as well, to the point now where this wharf has actually been repurposed for like a multi-use site where they're getting their extension of life out of it. So being able to take away the moisture out of the equation, stop the chlorides ingressing or elevating in levels, and really halting that corrosion cycle and pushing that curve out that Doug was speaking of earlier for extending that service life. Back to you for another mining one.
Yeah, thanks. So another one site we've been involved in is the Mungari, the Evolution mine site. So again, challenges with the hypersaline groundwater. This was a recent extension being conducted there, and obviously being about 20 minutes out of Kalgoorlie, there's some challenges around the hot weather, pouring in, some very dry, hot conditions. So being able to provide admixtures that didn't contribute negatively to that and gave a good result in terms of the placing, pumping, not disrupting the standard concrete mix design, that type of thing. And getting that good result from day one, and then again being waterproof, protecting against that saline there. I noticed Hayden mentioned earlier in the presentation there was the wet dry cycling. This is very common on these type of projects. So we have got areas being washed down daily or every couple of days with the hypersaline water. And you get that wet dry cycling. Even you get a bit of heat to get very saturated concrete, then it gets very hot. It's very harsh for concrete in terms of breaking down that microstructure, attacking the concrete, and degrading that durability, that service life that you would normally expect to get in normal conditions. Back to you, Hayden.
Yeah, thanks. I was just thinking that even you see it on where you got a flow of like water against a tank wall or a pipe, very easy to see the loss of cover over some time through that period. So that wet and dry sort of type cycle. Now, this is the one that Doug referred to earlier. Obviously, we've done a lot through the marine sort of mining infrastructure sector, water treatment, etc. But what I just wanted to just quickly talk about this one was this dates back a long, long time before MARKHAM were actually involved with hydrogels. We've been now involved for just about 30 years in Australia and New Zealand, protecting concrete. But this here's a old structure in Vancouver, and obviously the acid rain is a component there, but also de-icing salts is obviously they're good for what they do with snow and making it safe, but very harsh on concrete. But what was looked at here was there was a side-by-side comparison of a hydrogel treated concrete versus an untreated area. And you won't be able to read that report properly, but essentially what it says is by Gordon Spratt. It's a independent engineer. They went back to this, and it was after 18 years in service. So through those cycles that we've just been speaking about, and the treated area is still being able to see the original profile of the concrete finish. So the trail marks and how it was left as finished. So that was how it held up in its durability compared to the untreated area that showed very, very a lot of wear over that period of time. So a clear example and a report to show that side by side. So hopefully that makes sense. It just probably just helps to show the long-term durability or the long-term effect. It's not just extending your service life for a matter of the first component or the first period of time, but it's that long-term effect. If you can protect that cover concrete, you're getting a lot more out of your structure. Hope that makes sense. Back to you.
Yeah, cool. So last project we want to have a look at here was the MARKHAM mine site. This is a very unique site. Has some very harsh conditions, obviously the hot and dry, windy, and the processing plant there has some very aggressive chemicals, shall we say. And what they were finding is that the damage that you can see in the left there, the pitting and that cracking, the gouging out along that crack there, was happening at around the 18-month to 2 years period, and it wasn't long from there that they would have to be breaking that concrete out and replacing it as they, it was bunded areas. They needed to have that protection from, those chemicals getting into the ground. So they switched across about 5 years ago to the hydrogel admixture. They also spray applied it with a hydrogel curing treatment, and then obviously carried on, did the epoxy coating following that. What's really interesting is you can see in the right-hand picture there, just below where the arrow's pointing, is a crack. And normally what would happen is that once the chemicals would get through the membrane, get into that crack, you would start to see the damage that you're seeing in that left-hand picture. With the hydrogels, because it stops the acid, stops the chemicals going past that very top surface and stops it going horizontally into the spreading in the concrete matrix, you get a lot better service life out of that concrete. So that damage mechanism that you would normally see isn't happening in that environment there. So yeah, again, this site was aggressive chemicals, acids, that type of thing. The washdown water, I'm not sure on the salinity of this here, but I'm imagining it's high and also has other chemicals by its nature. And that's getting washed down regularly. It's having to deal with leakages, spills, that type of thing. So yeah, very harsh environments, and a real true testament to, if you get that get that concrete sealed up and that porosity blocked, you go a long way to getting a long service life, or getting the best service life out of the concrete. Well, I think that pretty much wraps us up. Back to you, Brendan.
That's really good. Thank you very much, Hayden and Doug. And thank you too to everybody who's been putting entries on the questions in the comments. Good to see some familiar names in there. Great to hear from everybody. We've just got a few questions come in here. If you wanted to, I'm not sure who to address them to. We've got one saying, what's the best time to apply this on concrete? We may have passed through that a little bit in the presentation. What would you say, Doug?
Yeah, no, that's a good question. So first up, if you can use the hydrogels as an admixture in the concrete, is the best. So you're getting that protection from day one, from the day the concrete's poured. But if you do miss that window, or if it's damage starts to manifest further down the track, or it's unexpected, whatever it may be, you can spray apply hydrogels at any stage of a structure's life. It more comes down to whether it's worth it from an asset management point of view. If it's just starting to manifest, or you've just done some repairs, that type of thing, that's the perfect time to apply the hydrogels and get that stop those damage cycles happening, and push that service life out. You got anything on that, Hayden?
No, that's right. You can go to any age concrete. It's as long as there's access to the bare concrete. So if a curing or coating has been put down, that would need to be removed. But we can access any age concrete. So it's good.
Very good. I've got a question around what was the dosing rate comparison versus the calcite?
That's an interesting one. It's a good question, because that is a consideration, especially in remote sites where, or the just general logistics. Now, generally, we work with the dosage rate, and we work on the cement content of concrete. But generally, we are between sort of 2.5 to 3 litres of product per cubic metre. And I think, what's the question about the comparison to calcite? I think there are somewhere around the 30 litres per cubic metre. So a lot more product, or it's 10 times or 10 times less for the hydrogel to go in there. Hopefully that makes sense. Hopefully that clarifies it. So a lot less logistics from even freight or point of view, getting to site, all those sort of things. Yep.
We've got a comment around the chloride diffusion values showing being quite high for high durability concrete. Did you want to speak to that, Doug?
Yes, yeah, no, I'd agree with that comment. The challenges there was dealing with a remote site and conducting trials there. Obviously, you don't have the controls and things that we do in a laboratory situation. But what I would say is that even when you have got those factors that you don't have control over in a lab, you're still showing good results there, as far as a comparison goes. And yeah, we've definitely been back and given them some advice around the mix design, things like that, because there's some improvements that can be made there for sure. So appreciate that comment.
Probably, yeah, I agree with that, and we do realise that. Thanks for that comment. But the other point on that, Doug, it does show also the life example of the actual conditions or the actual concrete we see in the field versus what we're doing in the lab. But we are always running lab tests as well, and appreciate any input into getting these as per results you want to see. So it's good.
Okay, now we've got a question around comparison versus certain Zypex products. I wonder whether that might be something we could perhaps take offline regarding specifics, if that's all right.
Yeah, I'll just touch on that quickly. I'm just looking at that question, just touch on that quickly. Obviously, there's a lot of powdered admixtures out there, which have been sort of the traditional approach. And that takes up a lot more moisture and can lead, if it's not cured right and not worked and placed right, it can lead to excessive cracking or unexpected cracking and dry and shrinkage, those sort of things, and workability, placeability. So it's got to be careful about that with your mix. And yeah, absolutely, we can be an example for that, but more than happy to follow that up offline. Yeah.
A question whether it's been used in conjunction with shotcrete and underground ground support. One of those case studies had an underground structure. Hayden, is it shotcrete or?
Yes, actually do a lot with shotcrete. The beauty of it is it can be, it pumps very well to the point where they can actually pull back on some pressure in their pumps, so you can reduce things like your rebound and stuff as well, so you get a better concrete out of it overall. We have added it both at the nozzle and through the concrete mix, so 100% do a lot with shotcrete and those underground and get that. Because the hydrogel's set up right from the start and reacting with the alkalines and the cement and the water and the concrete, you're effectively waterproofing from day one. So you're giving that protection to the concrete and to what you're protecting against right from the start. Any more comment on that, Doug? No,
other than that, yeah, just to highlight what you said, the workability, lowering those pump pressures, things like that. There's some good advantages there. But yeah, 100% can be used and has been used in that situation.
Very good. Another one for you, Doug. Is it compatible with ammonium nitrate?
Yeah, I'm just thinking about that question. Is that in terms of if that's being exposed to the attack from that? It's probably something we need to do a little bit more work on there. But if it is a contaminant that gets into the concrete and breaks it down that way, the stopping that moisture, transferring it into the concrete is is what the hydrogels do, and you do see that protection there. I probably need to get a bit more info on that one.
Follow that up afterwards. We've got a question or a comment around Murrin case study, which had issues with ammonium sulfate. Most acid and ammonium sulfate areas are protected by coatings, where the deterioration issues related to failure of the coatings. Lost you, Doug. Sorry,
there we go.
There we go. Sorry, Doug, did you get that question?
Yes, yeah. No, that is those areas do have coatings. What we did notice in those areas was because they were putting that on fairly quickly after the concrete pour, and the concrete wasn't getting a good result in terms of, there was a lot of cracking, that type of thing with the weather, the environment there, and that when they go to put the coating on, that obviously doesn't help the service life of that coating. But what I do want to highlight, and we covered off earlier, was that there's areas where you can see where those chemicals just go through that membrane and start pitting out the concrete and gouging out the concrete in those areas, which is kind of related to the cracking, but it's not. If that concrete was waterproof and protected properly, you shouldn't see that gouging and that pitting of the concrete, and that's what we were able to prevent, or significantly slow down to the point where you only see a very thin line, or very localized point where that's gone through the coating there. Another point on that was the bond that they were getting between the coating and the hydrogel treated concrete was a lot better than what they were getting with the previous crystalline admixture and curing membrane that they were using there. So yeah, there is always a few factors that it's always kind of a package deal, if you like, to getting a good service life, good durability concrete there.
Very good. Question around a desalination plant. One of the issues with reject brine is a combination of elevated sulfate and magnesium. I think that's in your court too, Doug.
Yeah, that is a common factor there. So with the even in seawater, you do get some sulfate content, that type of thing. Obviously, it's elevated in the brine water situation, and with sulfate attack, what happens is that it gets into the concrete, again helped by that moisture, and breaks down that surface and scales off the surface. Now, if there's no moisture to feed that ettingite formation, or that that scaling, that expansion forces of that sulfate attack, you go a long way to preventing or slowing that attack right down. So I guess it's another advantage of a high durability, low permeability concrete, that you protect against that sulfate attack. There's actually a good article on our website we can probably include in the follow-up email to this event that goes over that very topic as well.
Very good. Just to comment again around chloride diffusion values, which probably relates to the discussion earlier. Question on applying to existing concrete, can you paint over it? Then a question on abrasion resistance and stormwater concrete pipes.
Yeah, good questions. I can talk to those maybe. Yep. A couple of things in there. The compatibility is a big topic. We probably should have covered that earlier. So it's a good question. Like when we're applying to new or existing concrete, what the subsequent coatings, adhesive, paint, line marking, floor coverings, all those type of things. And thankfully we can say we're compatible. We've done this, and especially in the floor coverings market, for 25 years plus. So a lot of different adhesives, paint-ons, epoxies, coatings, all those sort of things have gone over us. And why it is, we're colloidal silica based. So essentially we are just creating more calcium silicate hydrate in the concrete. So that's already in the concrete. We're not adding anything more foreign, if you know what I mean, that will react with your paints or subsequent finishes. So this is that point. Abrasion resistance is a good topic. So not a big part of what MARKHAM does is even into like the car parking space or warehouse logistics type space, but also for these hypersaline type environments where abrasion, trying to increase that abrasion resistance. And probably just looping back to that, there's two things. We'll share the Brisbane case study where we had a side-by-side example after this, but also just looping back to that Vancouver report where there's a clear, you could still see the original finish, so the trail marks or almost like broom finish type example versus untreated area where there's a lot of wear. So not saying that would keep that profile forever, but would just extend that service life and make that top surface a lot more durable, so increasing abrasion resistance, yes. And then stormwater, wastewater, pipes, all those sort of things, yes, have done a lot of that over time. Obviously, precast does have a tighter finish. It's more closed off porosity, but we can still, due to the nano size of the particle of the colloidal silica, we can still get into those environments and protect those type of things. Best to do, if possible, is include it in your mix when you're doing precast elements and get it right through that protection. Hopefully, good question, thanks.
It's very good. I see we just got a couple of typing. Here we go. Question, are the products industry approved? Example, Transport for New South Wales or RMS, B80 spec. That's been part of your domain in the past, Hayden?
Yeah, interesting. We do a lot of work with a lot of different road authorities, actually. And Transport New South Wales will do a lot of their structures. As far as the RMS B80 specification, that's quite specific in what it's looking for. But in saying that, we have done, I'd like to talk more, or if you've got project specific on that one, it'd be interesting. We have done a lot of work there, same with like TMR, main road structures across the New Zealand, NZTA, things like that. So we have got a vast track record with roading infrastructure. Okay.
I think we're pushing a little bit for time. I think there might be one more question coming in. Is there any modification to the mix design required, particularly when using super plasticizers? Does the hydrogel modify the slump, for example? And it's a good question. It hasn't been covered already. Either of you, Hayden or Doug, could take that one up.
Yeah, I'll jump in. So, no, that's a great question. That is one advantage with the hydrogels, is that we work with your approved mix design. So if you've got an improved 40, 50 MPa, whatever it may be, mix design, we can be added to that mix, and you don't change any of your water reducers or super plasticizers, anything like that. Just keep everything the same. There is situations, as people get more familiar with it, that they can pull back a bit on some of those super plasticizers, that type of thing. But straight up, we wouldn't change anything there. And in terms of the slump, it's much the same, but it is, you need to be aware that when you're adjusting slump, you often don't need as much water added to that to increase the slump more. So it is a bit more sensitive than a control concrete there, but nothing that's not workable with what you're doing out on site, type of thing.
Very good. I think this might have to be our last question. Thank you very much. And it's my favourite. If we hadn't had any questions, I would have asked this one as a stock standard. What is the lifespan? Do you have to reapply every 5 years?
Absolutely. No. No, that is the beauty of it. We probably should have covered it. It's permanent treatment. Once you can't reverse it, as I was saying earlier as well, what we're doing inside the concrete is building more of that calcium silicate hydrate, so it becomes permanent. It becomes part of the concrete, part of the structure, and it's not a reapplication. It's not something that's on the surface. It's all internal acting, so it's not subject to like wear or what's happening on the surface. It's all protecting the concrete integrally, and therefore no need to reapply. And lot of life examples of that now, especially in marine sector, wharf structures, roading structures, all right through commercial construction, a lot through. So a lot of, that's a good question, but especially thinking of a, you get a lot of different maintenance products, coatings, silicyoxanes, even talking about cathodic type protection, those sort of things, where it comes with a maintenance schedule. And thankfully we haven't been with this product as not needed. So it's good.
Excellent. And thank you very much to you both, Hayden and Doug, and for everybody who's joined, and brilliant interactions. Very much appreciated. If you have any other questions, we will be sending out a follow-up email with contact details to come. So we'll be able to, you can be able to get in touch with us afterwards with any further questions that come to mind.
Thank you.
100%. Thanks for jumping on. We'll, as Brendan said, send out this. Please give us some feedback too. But we'll put our email addresses on there. Fire back anything. You got some project specific stuff. There's a couple came into the chat, so keen to chat and we'll catch up and go over some detail. Thanks all.
Very good. Thank you. Have a great day.